Hey, Vlad here, devincid.com. Welcome to another video. As announced in the previous video, we're about to create our own tiny collections library. But before that, we're going to create a small project to play around with the existing one, just as a showcase what a well-written library has to offer. We'll write a command line tool which will allow us to validate credit card numbers. And also, as a byproduct, it will be capable of generating valid ones. Alright, enough talking. Let's write some code. As always, we're in the Ubuntu virtual machine and we have Sublime on the left and the regular terminal on the right, which runs SBT, which runs our code every time we save the file. So we have our regular project on the left. Let me actually open the left panel. So we have a regular folder with source main Scala, and it has a main file with a main object in there with a regular main, the same one as we always use, and it's a regular build file which just basically specifies the version, the organization, the Scala version, and it also makes sure that every time we save the file that it clears the screen before it shows out the next compilation cycle. This is not going to be a multiple project, so we're just gonna we actually don't even need this in this build. I'm just gonna remove that. Okay, so what I will do, I will just keep the existing project, and by the way, we'll also specify the SBT version the same as before. Nothing fancy this time in terms of SBT. So I'm just gonna rename the folder over here, and we're gonna call it simply credit card, right? Like this. Okay, and now it says no main class detected because SBT doesn't know that the folder has changed. So we're gonna exit over here. I'm gonna go over there. So now we have the Scala playlist and the credit card. Actually, we probably don't need the Scala playlist as of right now. So we're just gonna go to the credit card like that. I'm gonna press Control L, launch SBT again, and it's gonna take a few seconds to launch. And now we're gonna do tilde run. There we go. Tilde run, and we should see exactly the same thing. Okay, somehow I need to close these files. Hold up, there we go. Somehow Sublime didn't notice that the folder is gone now. Open recent, dev credit card. Let's close this one. There we go. Okay, so this is exactly what we see. So now it's called credit card, and which is why SBT is also saying in the beginning when we started it. Hold up. Let me start it again real quick. That's why it says set current project to credit card. All right. So we can run our main method again. All right. So for a while we're gonna switch just to compiling. Okay. And what we're gonna do, we're not gonna test the main for a while. We're going to create a new file called credit card. Over here, credit card.scala, because this is going to be like a bit more as a library rather than a rather than a tool. We're still going to have a main method where we're going to play around with our API, but mostly it's going to be like a library. Okay, and we're not going to have like fancy packages or anything like this. We're just going to start writing code. So our main abstraction is just going to be a sealed trait credit card like this, right? And all it's going to have is a number. Which is a string. It's not an integer, it's a number. Okay, I'm sorry, it's not an integer, it's just a string. Okay, and we're gonna have a companion object called the same because it's a companion object, right? And we're gonna have two implementations of the credit card, right? So it's a very simple algebraic data type. Okay, so we're gonna have a final case class invalid number string extends credit card like this, and we're actually going to duplicate this line, and we're also going to have valid like this, and let me have two spaces over here like this. Okay, so this is our main abstraction, and this should compile. There's nothing fancy about this. Okay, so our clients will be able to create credit cards and pattern match on them, and this is how we'll be able to see if it's a valid card or not. But we'll also add some convenience methods over here. We're going to say is valid. So instead of doing the whole pattern matching, they will just be able to call is valid, and it will just check the type for the user, right? So it's just going to do is instance of valid, and for that to compile, we will need to import credit card. Import credit card. So we're importing this companion object right over here so that we can access it over here, right? And we're also going to have a convenience method called is not valid, which is a boolean like this, and just going to do it is not valid like this. All right, so that also still compiles. So the idea is the following. So we're going to have a function called apply over here. And you know what, maybe I should switch to having it like that, Sublime at the top, because the lines are getting sort of longer. So let's do this. And so the idea is that we're going to have a function called apply over here, right? And apply is going to get a number like this, and it's going to produce a credit card. And then what it will do is it will say if is valid, and is valid is not this one, right? So is valid is going to be a function that we're going to define in just a few seconds, right? So if it's valid, then it's just going to construct a valid number, right, like this, and otherwise it's just going to construct an invalid number, right? And this should be the only way to access these constructors. And there's a way in Scala, I'm not sure if I've ever mentioned this, but there's a way to make the constructor itself private, right? So the constructor is now private, and because it's a case class, oh, hold up, wait, I forgot to private to define the is valid function, right? Which is gonna, take the number, which I forgot to pass in over here. It's gonna take the number like that, right? And it's going to produce a Boolean, and for now we're just gonna say false, right? False. I just want to get it to compile. Okay. So now the constructor is private, but remember that this is a case class, and for a case class, a companion object is being generated with a factory method. So in fact, if we go to main, and let's see if we can construct an invalid credit card, for example, right? So let's see if we can do credit card dot valid or invalid, doesn't really matter. Let's pass something in. Let's see if that compiles. And as you can see, it compiles. So even though the constructor is private, right? So we can't do this, right? The companion object is still private. I'm sorry, the companion object, the apply method in the companion object is still public. So we'll actually have to fix that. In fact, let's fix this right now. So what we'll also do over here, we'll say object invalid, right? So it just has to have exactly the same name, and it has to have exactly the same factory method, so to say, and it will produce an invalid, right? And we're gonna make it private. That's the whole idea, right? So we're gonna make it private, okay? And it will produce an invalid card, and this is now an endless loop, right? So it's just gonna call itself. So we have to make sure that we're calling the constructor over here, right? So we have this now, and it says method apply and object invalid cannot be accessed in object credit card dot invalid. And where does it say that? Credit card 26, which is over here, right? So now we can't even access that. So what we can do is we can do private for the credit card like that, right? So now this one can access it, and in the main now we can do this, and we also should not be able to do that if we actually take the invalid one. I just fixed the invalid one, right? So if we do this, now it's going to say method apply and object invalid cannot be accessed, right? So we're going to do the same thing. Let me remove that. Whoops, I removed a curly brace like this. Let me remove that, go back over here. I'm just going to copy that, and yeah, let's put it over here. Call it valid, like this. Same idea, right? Okay, so again, the idea is that we're going to be able to create credit card numbers like this. So we will be able to, let's remove this. We should be able to say just credit card, pass in some number, right? And we should be able to check if it's valid or not. So we can wrap this thing into a print line, and it should at least compile. Yet another thing that we want to have is that in the second part of the video, we're going to be able to generate numbers. So we're going to have an alternative apply function apply, which is not going to get anything, right? So it's not going to get anything, and it can produce a credit card, but we can provide an even better API if we actually return a valid card, right? Because if we don't generate a valid card, then it's only a bug, right? So we know automatically that it's a bug. So let's encode it into the type system, right? So over here, we're just gonna create a valid credit card by passing in a generated number, and the generated number is just going to be a private def over here, generated number, some string, and let's just pass in some numbers like this. Okay, so we should be able to create a credit card like this now without anything, and it's probably going to be invalid. In fact, let's run this. Why not? So if we run this, it's going to say, okay, it's going to say true because is valid always. What does it say true? Hold up. So it comes over here, generate number is over here. So it creates a valid one. And because it's an instance of valid, right, it says that it's a valid card, right? So as of right now, it's obviously completely bogus, right? I just wanted to get it to compile. This is why I wasn't even trying to run it. So let's actually switch back to compiling. Okay, compiling. Okay, so for now we're gonna be done with this code. We're just gonna go to main, and we're gonna finish the main now, because as of right now, in terms of the public API, we're pretty much done. So let's finish the main for now. So what we're going to do is, we actually haven't played with this too much, but every time we start the application, we're actually passing. We're able to pass in the arguments over here, right? So let's for now just say print line args dot head option. Okay, so now if I just run, then it's going to say that this array of strings, a bunch of strings, that at the first position, right, at the head, there was no argument, right? But as soon as we pass in some argument, some number, for example, or we pass in some string, then it's going to construct a sum, okay, over here. Right, so this is what we're going to do. We're going to start with an args head option, because the idea is that we should be able to run our main with an argument or without an argument. And if we run it with an argument, then it will just construct a credit card and try to validate it, right? And if we run it without the argument, it's just going to run a tiny demonstration, right? So as of right now, if we do head option, and by the way, this is why we're here, right? So we're demonstrating. I want to demonstrate to you what a collections library can do, because arrays are a part of the collections library. So the return type of this is actually, let me remove the cursor, is an option of string, right? And an option of string has a function called map, right? And we can map it to a credit card. Notice that this is not going to compile. Let's actually switch back to compiling. Right? And let me save this file. And that's not going to compile, but it will compile if we do .apply. And this is a good indication for you. Every time you're creating an object which contains an apply method, it's always advisable to also extend a function, right? So we already have where is it? Our credit card over here. Why don't we just extend also a function that takes a string and produces a credit card? Why not? Right, so now this code is going to compile, and this in turn produces an option of credit card. We're going to talk about all of these methods, like for example head option and map, once we're going to start creating our own collections library. Right now it's more like a crash course, more like a demonstration, so don't worry if you don't understand this in detail. Okay, the next step that we're going to do is we're going to call map again. And we're going to just print out the credit card, and the return type of this is going to be an option of unit. And if it's empty, then we're going to say get or else, and we're just going to say run demo. And run demo is just going to be a tiny function over here, private def. In fact, code can also be private. There's no reason for it to be not private, right? So it's going to be a private function, run demo. And for now, it's just going to say running demo. Okay, so now if we run this, without an argument, it's going to say running demo. And if we run it with an argument, it's going to construct a credit card, right? It's going to print it out. It's going to say that it's an invalid credit card, right? And that's pretty much it. So it's basically going to validate the credit card. So our run demo is going to do the following. So as a first step, we're going to create a valid card, which is going to be a type of credit card dot valid, because remember in this case we're going to call this one the constructor without the parameters, and we said that it should always return where is it, this one, that it should always return the credit card of type valid. So I'm also making sure, like this is optional, right? So Scala can infer this type. So if I do this and I go back to compiling, right? In fact, I can actually go back to running. Okay, so if I run this, it's going to compile because Scala is just going to infer the type. But I just want to make sure that I don't ruin it accidentally over there, so that it always generates a valid credit card. Not only valid credit card, but also the type should be a valid credit card. Okay, so we're just going to play around with it a little bit. So we're just going to print it out, and we're going to also print out the number, right? And we're also going to print out the is valid boolean, right? And we're going to do exactly the same thing with an invalid card. So we're going to go down here. We're going to say invalid card over here, invalid card, and invalid, oh, not vard, card, right? So we're just going to pass in some number here, like 1, 2, 3, 4, 5, 6, 7, 8. And I think when I was playing around with it, I just did it twice, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, like this. So this should be an invalid card. And if we're calling the factoring method that accepts a string, remember, it just returns a credited card, not the valid one. So it's going to look like this. Okay, so if we run it now, and then also let's have a print line between them, like this. Then we're going to see a valid card, and we're going to see an invalid card, right? And as of right now, we should be done with the main. In fact, let's do one more thing. Let's actually improve the toString method of a credit card so that it's just more, more visible if the card is actually valid or not. So we're going to go to the trait, and we're going to override the toString method. So we're going to say final override def toString, which returns a string. I always prefer to specify the types, especially when I'm recording educational videos. All right, so over here we're just going to say, okay, if it's not a valid card, then let's have a tiny scope over here. Whoops! Oh, I pressed insert. Damn it! There we go. I pressed insert. Okay, so if is not valid, then we're just going to have a tiny scope over here, and we're going to just create a string interpolated string. I have to find a way how to say this more properly. So we're going to say invalid and credit card number, and just show, whoops, just show the number over here, right? Credit card number. And invalid is just going to be a string over here. We're just going to make it more visible, as you already know by now. I like colors, so we're going to do this and we're going to do that. All right. Also the reset, and otherwise we're going to do something very similar. Right. In fact, let me copy that. I'm going to copy that. I'm going to paste it over here. Right. Invalid is going to become valid. Right. I want this to be capital. I want this to be, oops. I want this to be green. What we'll also have here is going to be with payload and check digit. Same as before, like this, check digit. So what you need to know about credit cards is that the last digit is just a check number. So the numbers that are before, I'm going to call them payload. I don't actually know how they're properly called. And then there is an algorithm called the Loon algorithm that we're going to implement, and it basically goes through these numbers and does some modifications to them, and then adds them all together. And then if the sum of this whole payload plus this check digit, if it's divisible by 10, then it's a valid credit card number. All right. So what we want to have here is we're going to retrieve the payload and the check digit just by calling a function called split that we're going to put into the companion object, right? So we're going to give it the number. It's going to return us a tuple with a payload, which is a string, and with a check digit, which is an int. And maybe we should go and implement it right now. So we're going to go to the companion object. Somewhere here is valid. Yeah, let's put it under is valid. Let's put it over here. So it's going to be a private function, and it's a private function in the companion object, which means that the trait can actually access it. Okay. Okay. So we have private def split, which takes in a number, which most functions over here are going to take in a number as a string as its argument, right? And as I already said, it's going to produce a tuple, which takes a which contains a string and an int. Okay. And the payload is going to be number drop right check digit length, right? So check digit length is just going to be a tiny val over here, right? Actually, let's also make it private. Check digit length, and it's going to be 1, right? So it's digits. The length of a digit is always 1, so it's going to be the last, the last digit. Okay, and a number, which is a string, it can be looked at as a sequence of characters, right? So it's a collection. So collections have a method called drop right. So it basically will from right drop as many elements as you tell it to. So in this case, it's going to drop 1 element. So it's just going to drop last digit. So the whole credit card number without the last digit is the payload, right? And the check digit is going to be the opposite. The check digit is going to be number take right. So instead of dropping from right, we're going to take from right. And we're going to do check digit length as before, right? So it also goes from right like this. Okay, so from right it will take one character, which is the check digit. Okay, so let's have it like this. Okay. What you could also do, just, because this video is a demonstration of the collections library, you could also do, let's have it like this, number dot last element. So it will always give you last element, but we have a string, and the elements of a string are characters. So we need to convert it to a string first, and then convert it to an integer, right? Because I actually forgot to do it over here, because we need to produce an integer here, right? So take right, return the string, and over here we're going to say to int, similar to this, right? So all we need to do now is we need to actually return this tuple, right? So we need to return a payload, arrow to the right, check digit, right? Or as you remember, the alternative syntax would be like this, right? All right, so split should be done now. Let's see if it compiles. Okay, green doesn't compile because it's actually all caps. Green like this. Yeah, it compiles. So now it looks much better. So it says valid credit card number with payload, everything except for the last digit, and the check digit is 4. And over here it just says invalid credit card number, and it just shows the number, it says true, it says false. That's it. All right, let's start actually implementing the isValid function, not this one, but this one in the companion object, the one that is defined over here. So in the beginning, let's just do a lot of silly checks. So let's just say that number should not be equal to null, right? So if basically a credit card number is valid if the number is not null, and if the number is not empty, which is another method that you can call on most collections, actually all collections, right? So if it contains elements basically, and also that every number. So there is a method called for all, which is a higher order method that takes in a function that will go through these characters and make sure that they're all digits, right? So there's a function called isDigit defined on character. So we're going to make sure that every character in this number is actually a digit, right? And also it will make sure that we're going to construct a range here. So we're going to say minimum length to maximum length. Right, and these two are just going to be vals over here, where we had the check digit length. Where is it? Oh, it's over here. Okay, so we can't access the vals from down there, so we should have it over here. So we're going to have a private val minimum length, and I read somewhere that credit card should start with 13 characters. Right, this is the minimum as far as I'm concerned. And the maximum length is, as of right now, it is 19. So let's have 19 here. Okay, so this constructs a range, and what we want to ask this range is if it contains the length of the number, right? So remember, we're passing in some credit card number, and we want to make sure that whatever is passed in is somewhere between 13 and 19, which means, does this range contain the length of this number, right? And in fact, let me do this so that it's just a bit more clear. By the way, one thing about Scala is to know that it always returns the last expression. So if we had a scope over here, right, like this, if we had a scope and we had forgotten one of these, right? Actually, let's make sure if it compiles now. I mean, there's an end character over here. So let's remove the end character. Okay, so as of right now it compiles, but if we remove one of these, it will also compile. It might produce a warning. No, it doesn't produce a warning, but it still compiles. And I'm going to show you a better way how to do this once we're going to start talking about streams, like in 6 or 7 videos from now. As of right now, let's just leave it like this. And the last condition that we're going to have is going to be called does math check out, right? So if math checks out, so if all these conditions are true and math checks out, so this Loon algorithm does something proper, then it's actually a valid number. And does math check out is going to be a function that we're going to have just down there. Or let me remove the scope, we actually don't need it, right? Okay. By the way, I forgot to mention that the entire code is going to be in GitHub, so you can look at it at your own pace. I'm sort of talking too fast this time somehow. I noticed that my videos are like way too long, so I'm trying to make them a bit shorter. All right, so the function is going to be called does math checkout. Pass in the number, it produces a boolean as before. Okay, and the first step that we're going to do over here is we're going to deconstruct the payload and the digit again, right? The check digit. So we're just going to copy this. We're going to go down here. Okay, we're just going to insert this, right? Okay. So as I explained before, if we calculate the sum of this Loon algorithm that we're going to implement in just a few minutes, right? Which takes in the payload. So the Loon algorithm will return us a sum. It will return us a number like 67 or 75 or 100 or something like this, right? So if this number plus the check digit, right? If they are divisible, if this sum, if it's divisible by 10, right, modulo 10, right? If this equals 0, which means that the sum is divisible by 10, then it's a valid number, right? So as of right now, all we need to do is we need to create the Loon algorithm. Just takes the payload, produces an integer, and I just want to make it compile, right? So let's do 10. I just want to pass in some number, right? And I don't know, should we play around with it? 11, 12. Okay, so if we wanted to implement the Loon algorithm, we need actually to know much more about the collections library. There are some really cool methods defined on collections, which is also why we're here, right? So the Loon algorithm works this way. So we take the payload, right, and we call reverse on it. And when we call reverse, then this is still a string, right? So all the sort of mutation functions on immutable collections, which is something that cannot be changed, they don't change the collection in place. They actually create a new collection, right? So over here we have the string called payload, and once we call reverse, it will produce yet another string. It's not going to change the payload. It's just going to produce a completely new string that we're going to work with. Okay, so we reverse the string. Then we make sure that we're not working with characters anymore. So we map every character to a string first and then to an int. And this is going to be, I believe, an indexed seek of ints. Okay. Let me actually do it over here like this. There we go. So this is an indexed sequence of integers. Okay. The next thing that we need to do is we need to zip it with index, and what this will do is it will produce yet another indexed sequence. An index sequence is just a sequence which can be accessed by its index, right? So in this case, it's going to be an index of a tuple, and in the first position, it's going to be an integer, which is basically just a digit, right? And in the second one, it's going to be the index, right, which is also just an integer, right? So it's going to be a zero-based index, which means that the first element is at first element has index 0. Okay, so it's going to produce tuples, and what we do with these tuples is we're going to map them. And instead of a regular function, instead of a total function, we're going to use a partial function. Watch my videos about partial functions if you don't know what I'm talking about. So we're going to deconstruct this tuple, similar to as we did over here, right? This is pattern matching over here. We're deconstructing the tuple into payload and check digit. Same thing we're doing over here. We're going to say digit and index, and it's a zero-based index, right? So we have deconstructed them right now, and the Loon algorithm says that if the digit is in the position that is divisible by 2, then like this. So this means that the position is divisible by 2. So every even digit, then we just to duplicate it, right? So we need to double it, right? So we need to do digit times 2. Otherwise, we're just going to leave the digit alone, right? So the result of this is going to be yet again like this. It's going to be yet again an indexed seek of just ints, right? And we're still not done. We're still going to map this thing, right? So the problem now is that it generates numbers that are too large, right? So for example, if the digit is 8, then over here we're going to have a 16, and we don't want to have that, right? So what Loon algorithm says is that we take every digit then, and if the digit, if it's bigger than 9, which means if it has, if it's actually not a digit, right? So if it's actually a number, let's actually call it number. So if the number is bigger than 9, right? Then we're just going to subtract the 9, right? And otherwise, we're just going to return the number, right? And we're almost done. So the result of this is again indexed seek of int, and int in this case is a digit again. Okay, and as the last operation, we're going to do sum. In fact, let me actually do this I'll revert it. I just want you to see the whole thing at once. So this is the entire Loon algorithm. So we take the payload, we reverse it, we make sure that every character is actually a number. We zip it with index, which means we are creating a sequence of tuples with the first position in the tuple is the actual digit, and the second one is the index, which means the position, right? And if it's at an even position, then we double the number. Otherwise, we leave it alone. And then if whatever came out, if the number that came out is larger than 9, then we're just going to subtract the 9. Otherwise, we're going to leave the number alone. And then on this index sequence, so Scala understands that these are numbers and they can be added together, so we can just say sum, and it's going to produce this Loon sum. Let's see if it compiles. Let me actually move it back to over here. Let's see if it compiles. It actually does compile. Okay, so this is the Loon algorithm, and basically the validity is done. So all we need to do now is we need to generate a number, and generating a number is very, very simple. So we're just going to give it a length that needs to be generated. It can generate absolutely random bogus number. Then we're just going to calculate the Loon, and we're going to add the check digit, and that's it. So let's just do this. It should be actually real quick. Let's remove this bogus number like this. Okay, so very important. In the very end, we're going to have some number, right? So this is going to be some number, right? And we're going to say if is valid number, common if it's a valid number, like this, then just return it, and otherwise throw an exception, system error, and we're going to say that, sorry, that this is a bug, and generated an invalid number, like this number. Okay, and yeah, for now that should be enough. Like, it should compile at least, right? So now it throws an exception because is valid is actually working correctly now, and it says that this number is invalid. So in fact, if I do something valid like this should be the valid number. Did I do 1, 2? Okay, hold on. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 0. And there we go. Okay, it's a valid number. So how do we actually generate a number? Well, it turns out that we don't really need to. All we need to generate is the payload. So assuming that we had some payload, what's up with my keyboard? There we go. So assuming that we had some payload, which is, you know, something, right? Then all we need to do to generate the number is we need to take the payload and add it to the check digit. And how do we get the check digit? Well, again, assuming that we have the payload, the check digit is going to be, and this is going to be a little bit of math, right? So it has to be a digit. So we have to calculate this Loon sum, right? The Loon sum, right? By passing in the payload, right? Again, it's based on the payload, right? And it has to be a digit, right? So we have to do modulo 10. Everything modulo 10 is somewhere between 0 and 9, so it's always a digit. Then we need to subtract that from a 10, right? Because again, remember, the sum plus that something, this whole thing, modulo 10 has to be divisible, has to be the digit, right? So we take this again, and we have to do modulo 10 again, right? So one of these 10s, specifically this one, is again to make sure that the case with the 0 is at the very end is handled, right? So if you look at this right now, so this is some big number, right? So this is like 67 or 75 or something like this, right? So this modulo 10 is going to be somewhere between 0 and 9, right? So when we subtract that from 10, then in case of the 0, this whole thing is still going to be a 10, right? So it can't be a digit, right? So we need to do modulo 10 again and to convert this into a 0. So this will basically work for the case where the check digit is actually a 0, as we did when we were playing around with this one. If this one was a 0, this would actually be a valid digit. Valid credit card number. Okay, let's see if it compiles for now. Okay, it compiles, but it still throws the exception. That's absolutely fine. Okay, so all we need to do now is we actually need to generate the payload. So this is actually one of the very last things that are left to do. Okay, so how do we generate something? Well, in Scala we have the Scala util random, and this is going to be the basis for generating anything, right? So we're going to have a min, which is just an integer, right? So the min for the payload is the minimum length of the whole credit card number minus the check digit length, right? Which is 1, right? So the whole thing is now 12, because remember this is 13, this is 1, so this is 12. And similarly, the max over here should be 18, right? Because this one is 19 and this one is still 1. Okay, so the total length of the payload is going to be somewhere between 12 and 18, right? So in order to generate that, we need to take the random number, random next end. Now we need to generate a number somewhere between 18 and 12. So basically we need to generate a number somewhere between 0 and 6. So we need to do max minus min, right? So max minus min is a 6. And we need to add 1. This should be in the end somewhere between 12 and 18 if we add the 12, right? So if we start with the 12, right? So let me write this down. Okay, so if how do we do this? Let's do this, and let's do, so min is a 12, right? Plus, and over here it's going to be 0, right? So random next end generates a 0 until whatever is specified over here in the parentheses, right? So and over here we have max minus min is 6 and plus 1 over here, right? So plus 1. So this will generate a number from 0 till 7. Basically means the latest number that is going to be generated is going to be 6, right? So until is exclusive, right? So it's not going to generate the 7. It's only 0 till 6. So the whole number is going to be 12 till 18, right? So this is going to be the length of the card number that we're going to generate. So now all we need to do is first we're going to have a tiny helper that actually generates a random digit. So it's going to be random next end, same as we did over here, random next end, but this one is going to be much simpler. All we need to do is we need to generate numbers from 0 to 9, so we have to give it a 10, right? So it's going to be 0 to 9, because remember it's exclusive, it's until 10. The 10 is not going to be included. Okay, so now we're going to construct a range from 1 to length, right? And we're going to walk through this range again with a map. We're going to ignore the values. We're going to ignore the values because we just need to traverse something 19 times, maximum, 18 times maximum, so somewhere between 12 and 18 times, and we need to generate a random digit. Very important, you should have a def here, not a val, because if you're going to have a val, then you're going to generate, I don't know, let's say 13 times the same character, right? So we're generating the random digit, and then, like, this is going to be, okay, so this was a range, or actually I believe this is a finite range, I believe. I'm not sure. I think this is a finite range, and this is an indexed seek of an integer, and whoops, I already have the dot. Sorry, I already have the dot. So when we do make string, then it will generate a string. All right, a string, and there will be no separator. So make string is overloaded, so you can also do something like this, and then it will generate 1 comma 2 comma, it's just going to put a comma in between the elements. Or you can also do a start. So for example, you can do an open bracket like this, right? And also a close bracket at the end like this, right? So this is only make strings, but we're going to play with them much more once we're going to create our own library. And I believe that's actually it. So this should be able to generate a completely valid number, right? This is why we don't see the exception anymore, right? So this generates completely valid numbers. So the whole thing is going to be on GitHub, so you can look at it at your own pace. We're going to improve 1 or 2 tiny things in a second, but before that, let's go to main, and let's actually try something else. So let's create fake numbers. So let's go over here. Let's do print line, right? And let's create fake numbers. So we're going to go from 1 to 10,000, right? So this is 10K. We're going to map that. Again, we're going to ignore the thing. We're just going to, we need to do something 10,000 times, and this is how you do it. So we're just going to create a credit card number. Let me make sure to scroll down a little bit, right? So this is a fake number, actually fake numbers, like this. Okay, so let's see if all of the fake numbers, if for all, this condition is true. So if you're going to see true, then our generator completely works. I mean, that's actually not true, because our generator uses the same code to validate and to generate. So if there's a bug there, then it might what's it called? Cancel it out, cancel itself out, right? So what we're going to do instead, we're going to go to a website, and the link is going to be down in the description. This website is over here. So it has a bunch of data validators and data generators and whatever, and it has a credit card number generator. So these are generated fake numbers. So if I reload the page, it will be different fake numbers. So what I'm going to do is I'm just going to copy all of them. I'm going to go back to our code, and I'm going to do some Sublime magic. I'm going to maximize Sublime real quick, right? I'm going to call this more fake numbers, and I'm just going to paste them all in, and they're going to look a bit ugly, so just bear with me for a second. So we need to remove this, we need to remove that, J something, dinner something. So these are fake numbers, right? But they're all valid. Valid in terms of the checksum, right? So I'm not sure if this one is marked like this. I'm not sure. Oh, because it starts with a 0, so Scala Sublime syntax thinks that it's invalid. Okay, so let's remove that one as well. Okay, so if I mark them all and press Control-Shift-L, then I will have a cursor at the end of every line, and now it's at the beginning of every line. Shift-End. Let's do quotes. In the end, let's do a comma, right? So we can start by having a, let's have it as a set. So I'm going to put all of these in a set, and remember, since Scala to 12, even the last element can have a comma, which is kind of cool because I can take all of these, I can press F9, and now they will be a little bit sorted, and I don't have to worry about removing the last comma and add in another comma somewhere in the middle. Okay, so we have a bunch of fake numbers, and let's see if that compiles and if that runs. Yeah, it actually does run. Okay. So now we're going to go down over here, and the first thing that we're going to do is we're going to map all of these numbers to a credit card, like this. Okay, and I think this jumped. It doesn't really matter. Okay, so all of these are now credit cards. So this is a set of credit cards. So now what we're going to do is we're going to, first of all, we're going to split them into valid and invalid, right? So we're going to do more fake cards, more fake numbers. Did I say number again? More fake numbers, right? So another cool function on collections is called partition. So if I call partition and I pass in a function which is going to go through every element, and if it returns true, then it will construct another collection and put it into this one. And if it's false, then it's going to put this element over here. So it's basically going to take them apart and create two of them, right? So it's going to be partition them by the fact if they're valid or not, right? So over here we're going to say if invalid, not empty, right? Then we're just going to have an empty line, and then for every element we're just going to print it out. So if you don't see anything, then all of these numbers are valid. Yeah, so as you can see, we see true, but this true is coming from the previous code. So this true is coming from over here, right? So if I ruin one of these numbers, let's actually ruin two of them. Let's take the third one over here. Let's make a 2 over here, and also let's go to the fourth one and make a 5 over here, right? So I ruined two numbers, and right now we should see two invalid credit card numbers, and it's exactly these ones. So if I press Ctrl Z, then one of them is valid again. I run it again, so now there should be only one invalid credit card number, and this is really cool. Let me press Ctrl Z again, and let's have that. Okay, and as a very last thing, I actually kind of forgot it. I wanted to do it at the very beginning. So as a very last thing of this whole run demo thing, which ends over here, I believe. No, it should be over here. Yeah, it should be over here. At the end of this thing, we're just basically going to say print line, which is just a helper message for our users. You can say you can also pass in the credit card number as a command line argument like this, run, and let's give it some valid number like this one, for example, run, like that. Okay, so as a very last thing, and also let's have a print line over here, right? So we check out this project, we run this demonstration, we see a demonstration, and as a very last thing we see you can also pass in the credit card number as a command line argument like this. So if you copy this, right, press enter over here, I paste that in, it should say, hey, it's a valid credit card number, and if it's not a valid credit card number, then it should say it's not a valid credit card number. Okay, so we're almost done with the video. I'm just going to show you, I believe, two things. It's actually three things. The first one is, it's sort of simple, but basically you don't have to extend only one function. So remember our credit card, I said, if you're already defining apply functions, right, then you might as well extend the actual function. What you can do is actually you can do multiple ones, right? So you can also do with unit to credit card. Because remember, we have apply overloaded 2 times, right? So we have the apply that takes a number, produces a credit card, and we also have the one that generates them, right? So the one at the bottom, it's also called apply. It actually produces the valid one, but unfortunately the valid one is inside of the companion object, right? So we have the object credit card, and the valid one is over here. So over here it still doesn't exist, so we can't do create credit card.valid. Unfortunately, right? So always try to extend your objects with functions if you're defining the apply methods, but if it doesn't work, well, at least you try. And also, by the way, these two are doing the same thing, right? So this one doing the same thing, and this one is also doing the same thing, right? What's happening? Oh yeah, we actually can't do that because this function is private, right? And over there it's actually public, right? So let's remove that. Let's press Control Z. Okay, you live, you learn. All right, so the next thing is that every time you're defining a trait, look at your trait, and if it happens that it only defines defs, and as a default member of a trait, it should always be a def, but if you have only defs, consider extending, oops, there's an empty line, I like empty lines, consider extending any. So you can also do extends any over here. It's not going to change anything so far, but what it allows you to do is that in your case classes over here we have the invalid, we have valid. So what we now can do is we can extend over here any val, and only that makes in the credit card. It would not be possible if this trait was not marked as extends any. So if I remove extends any over here, then it's actually extends any ref, right? So then this thing at the bottom is going to complain. The same thing if we remove it. By default, everything extends any ref. Okay, so if you extend any, then we can extend any val. And we didn't have a dedicated video for any vals so far, but basically this is just an optimization. It means that when you say, for example, invalid, and you create a number and you pass in the number, that it actually doesn't construct an object behind the scenes. So what it does is it basically constructs just a lookup table. So it doesn't create objects. So it's basically a little bit more efficient to create objects. Well, basically it doesn't create them, right? So it's just a bit more efficient. Okay, the last thing that I'm going to show you is actually we actually have to jump in the console for this because we need to see the types, and I'm not using a full-blown IDE. I'm just using a regular terminal. Okay, so we're at the very bottom over here. Let me press actually I do Control L. That's perfect because I don't want to be like at the very bottom. Look at what's gonna happen if we create a credit card. So if you do credit card, right, and we pass in some number, doesn't really matter if it's a number or not, like this. Okay, so the type of it is actually credit card. Okay, but look at what's going to happen if we're going to create a set. So you're going to say set, right, and the set is going to contain 2 elements. It's going to contain a valid credit card, right, this one, and it's going to create an invalid credit card. 1 2 3 4 whatever, right, like this. Look, the type is Scholar Collection Immutable Set Credit Card, which is surprising. What I wanted to demonstrate is something like this. Hold on, I'm just going to hack it a little bit. Is instance of credit card dot invalid, like that. Okay, that's also not what I wanted to show you. Let me actually do this. Let me open these, because I want to demonstrate something important to you. Hold up, let me do this real quick. Okay, so we need to exit the console, enter it again. Okay, so now if I do set, and in one I'm gonna say valid, and I'm gonna pass in some number. So we don't care about validity right now. We just I want to show you something completely different. It has something to do with the types. Yeah, okay, so this is what I wanted to show you. Okay, so the type of this is product was serializable with any val with credit card, which is surprising, right? So what happened here is that it tried to find a common type, and the common type was this common type, right? Because we have different things in there. So what you can do to sort of improve the type inference a little bit, what you can do is you can just take this product with serializable, Remember, these are the ones that case classes mix in automatically. Rewatch my video about case classes if you have to. So what you can do is you can just take these and you can just put them over here, right, in your trait. And now this is not going to happen. So if I close the console, I open it again so that it recompiles, and I just go up like this, and I create the set, and now the type of set is actually credit card with any val, right? So, and if I remove this anything, right? So if I remove this, and if I do that, right, like this, then the type will actually be, let's see, the type will actually be credit card, and this is what you actually expect. Now it doesn't actually change much. It just confuses some error, confuses you because some error messages are going to be weird because of that, or basically you're going to confuse the type inference a little bit. So essentially every time you're creating an algebraic data type, which is basically a trait and a few case classes under it, then consider mixing first of all any, and then product was serializable as well. All right, so I'm just gonna exit the console, and I'm gonna go back to running our code, and I'm going to comment this in again like this, and also revert that like that and that. Yeah, so I'm going to upload the whole thing to GitHub, and in the next video we're actually going to learn about testing, right? Because this code over here, it contains quite a bit of logic, and so far we have tested it only through only sort of with our eyes, right? If we see true, then it's actually and it's actually all good. But if we look at our main, we're basically testing our code, right? So we're calling our APIs, basically testing our code. And in the next video, we're going to learn how to do this automatically. All right, it's been Vlad, devinsidey.com. Like this video if you did. Please don't forget that. It's really important for me. It helps me out. And yeah, subscribe if you want to improve the developer inside you. Most importantly, take care.